Constantly guarding your northeastern forests are sharp eyes looking for smoke. No, not this. Permanent smoke is what the lookout calls signs of residence and industry. He knows this smoke comes from a paper mill. But wait, has he found a new smoke? Does that faint column mean another demon is loose? Light-colored smoke generally comes from a grass fire, but there's a slope of pines in that area. Man fights time. Whenever he fights fire, it's a sudden and spectacular destroyer which every year in the United States covers a forest area equal to the size of New York State. Each spring and fall, conditions are ripe for this menace. Summer fires are also tough to handle. In truth, the best forest fires are those that never happen. As for those that do, it's everyone's business to know your enemy and understand the conditions that repeatedly put this demon in your woodland, and once there, how it behaves. From the lookout, the smoke appears bluish-gray as it billows up in a definite column. When seen close up, the smoke spreads and turns a telltale dirty brown color. Fire in the forests is a Bible phrase for an ancient enemy against which man's been fighting a winning battle only since the turn of the century. One of the first lessons learned is that the time between fire report and arrival at fire must be short. Fire control is easiest in the early stages. The start of organized fire control is in the memory of many men, some of whom are still fighting fires. The fire boss issues tools necessary to fight each particular fire. Correct decisions take training, judgment, and experience. Each fire presents problems which demand a different order of attack. Every year, there's some gain in the speed and efficiency of detecting and reporting fires and the work of controlling them. But the job keeps getting bigger. More people are using the woods. Additional forests are coming under protection, and fire detecting is becoming more accurate. Because of these changes, the total number of fires reported in the northeastern states has been increasing. However, the general trend is toward lower losses in burned-over area. Records of individual fire reports are mainly to help us learn about fire's behavior in the forests. Each burn is different in its rate of spread and in its severity. For instance, this is now a forest of gray skeletons and black ashes. But the damage doesn't stop here. A dead forest, carpeted with its own ashes, does a poor job of retaining rainfall. This is the first step toward land erosion and watershed damage. The factors which govern fire behavior are always the same. For the tenderfoot who is learning that sometimes the factors are wrong for even matches to burn, too bad. He doesn't get his second-class badge. Adults, too, should know more about factors which govern fire behavior. The big lesson is that the very same factors which make forest fires work in many different combinations and with varying force. Any fire warden could have told the campers this day was dangerous for building a campfire. Foresters know when fires are likely to happen and how bad the burn might be. They understand the three main conditions which control fire behavior: fuel, weather, and slope. Let's Let's look into these various types of fuel. For instance, green fuel. This sample happens to be maple in early summer. Green grass has the same fire characteristics. A fire source is lighted. That isn't smoke, it's steam. The fire has to dry out the water before the fuel can burn. These green fuels are not dangerous in summer, except when it is very dry and windy, or where large fires are underway. Next type, slow-burning or heavy fuels. These are generally bulky logs, stumps, or snags. Because this is a heavy fuel, little burning surface is exposed to the air. Heavy fuel dries out slowly and is slow to catch fire and burn. Under the right conditions, given a chance to dry out, heavy fuels make hot and dangerous fires, which are difficult to suppress. Flashy fuel types, such as dry grass, dry leaves, and twigs, blaze on contact with fire, burning easily and quickly because they are thin and air can get all around them. Affecting the burning of all types are fuel arrangement and continuity, where the speed with which a fire progresses depends on the pattern of the fuel distribution. Fuel quantity, where a fire may burn fast if it can run from one piece of fuel to the next. Or slow, where fuel may be patchy and broken up by roads, bare earth, or rock. Another factor affecting burning is the season of the year and its relation to vegetation growth in the forest. In winter, vegetation is cured. Spring is a transition period. Growth begins. Vegetation is green and reaches full growth in summer. Fall is a transition period. Leaves dry and drop to the ground. Fire will spread. Fuel moisture is still another factor which changes as the seasons follow each other through the year. Moisture begins to build up in the fuel during the spring transition period and reaches its peak in summer. The fall transition period reduces moisture by drying and curing fuel. The second main condition which affects the behavior of forest fires is weather. It takes about 5 minutes for a tower man, guard, or weather observer to read his instruments and record the observations. His first concern is to determine the fuel moisture content, which changes as rapidly as the weather fluctuates. This simple measurement brings together the weather factors of humidity, temperature, and evaporation, and shows the changes that are happening. Temperature differences and evaporation changes are easy to understand. The part they play in affecting the amount of moisture in the air, and consequently in the fuel, should be made clear. That white cloud blanket in the valley is 100% relative humidity. Nature's own backpack pump has wetted down this forest. No worry about fire now, but wait. The sun does its chores, raising the temperature, which in turn increases evaporation. When the relative humidity drops, the air dries the fuels, and then we do have to worry. Relative humidity is nothing more than a measure as to how much moisture is in the air compared to how much it will hold. When it reaches 100%, dew collects or rain begins to fall, building up the fuel moisture content. Fire danger is obviously very low. These conditions made the tenderfoot fail his campfire test. After sunrise, the day grows hotter and drier. Relative humidity drops lower and lower. Air dries the fuels, and fires spread rapidly. When the humidity goes below 50%, this is nature's danger signal. Wind is another aspect of weather. Wind velocity is of first importance in affecting rate of spread if fuels are dry enough to burn. We must know the degree of air movement in the forest. Is this wind gentle? Is this moderate? Is this strong? Wind cannot be estimated. It must be measured. If an area where there was no wind started to burn, the fire would spread like a growing circle. Blow up some wind, and the fire is fanned to burn faster in a definite direction with an elliptical shape, blowing flames toward less dangerous or more inflammable fuel. Change the direction of the wind, and the fire faces about, running with the new breeze. To examine slope, the third condition that affects forest fires, we'll go to Haldeman State Forest at Elizabethville, Pennsylvania. Here at the State Forest Headquarters, the Chief Forest Fire Warden has built a model relief map of the surrounding area that will demonstrate slope and fire for us. He calls it a fire control training map, and it's now duplicated in various regions throughout the country. Built to the scale of 1 foot equals 1 mile, it serves as a practical training device as well as a demonstration aid. The table is a composite of all terrain, giving us a bird's-eye view of the natural fire breaks, such as roads, streams, lakes, bare fields, and all. Assume that the material he is spreading is natural fuel. Actually, it's only colored wood flour and saltpeter. It's just like the real thing. As the fuel burns, notice how the natural fire breaks first slow up or completely stop the spread of the fire. Some slopes burn more easily. They face the south, where they dry more quickly due to the sun evaporating all the moisture. That's why they make for fast-spreading fires, which are tough to fight. But fire isn't the same on all slopes. For instance, uphill slopes normally burn hotter and faster. Rising hot air creates drafts to fan the fire. But once the fire goes over the ridge, the downhill slope normally burns more slowly. It has to burn against the in-drafts of cool air. Even though this is only a forest fire in miniature, it must be suppressed. Our Chief Forest Fire Warden will use this stylus, scaled to simulate a 10-man fire crew building a fire line. To fight any fire, big or small, first, stop it from spreading. Starve the fire by cutting off its fuel supply. Second, put it out. Put the fire dead out. Cut off the air supply. Put earth on the fire. Mix live ashes with mineral soil. Bury it. Or lower the heat to cool down the fire with water under pressure. Time of day affects the basic conditions that make fires. It increases the fire hazards of the fuel, the weather, and the slope. With the dawn, the sun warms the atmosphere and the earth. Relative humidity falls. Around 10 a.m., moisture-free air begins to circulate and dry the fuels. It becomes windier and drier, increasing the hazards of warm, dry fuels as the day goes on. Around 5 p.m., as the sun drops lower, the air grows cooler, the relative humidity rises, wind velocity falls, and fuels become less dry. In the old days, the men who watched our forests also knew that fuel, weather, and slope, combined with the factors of moisture, wind, season, and time, somehow added up to each day's burning possibilities. But fire forecasting hadn't kept strides with scientific developments such as the Deluxe car of the day. Rather, they operated according to certain unscientific, rough rules of thumb. These rules were derived from popular experience and were highly useful to men in terrain familiar to them. From observations and from working on fires, the old-time foresters could estimate peak periods of danger in a limited area. For instance, wind velocity was measured by smoke drift and movement of trees. Opinions of fire danger were based on simple things, on the extent to which a pine needle would bend without breaking, or the ease with which a hand could crush hardwood leaves. They were agreed. This was a fire day. But was the danger extreme, moderately bad, or just average for the season? In those days, they were never too sure. Today, the modern forester makes use of the research and development of forest experiment stations. In the laboratories, experts work on forest fire research, timber management, soils, tree and plant disease, and pest control. Much has been accomplished in developing lookout systems and instruments to detect and report all fires. One important development was the fire danger meter. Here, all the variables that make up forest fire danger have been reduced to a simple circular slide rule, which, when properly used, registers the burning index of each day. The meter adds up the ever-changing details. Fire danger ratings are reliable because of the careful research and experience applied in the system and the accurate information used in the daily computations. Several times a day, measurements of fuel moisture are made at each danger station in the woods. The moisture sticks are weighed on this scale to give a numerical value to the amount of moisture in the fuel. Wind velocity measurements are made by timing the interval between buzzes. A simple electrical system translates the speed of the twirling cups into a delayed sound, which is measured with a sweep hand. Standardized equipment and methods keep constant check on nature's pulse. Precipitation is also recorded. A simple graduated ruler measures the catch of rain. These measurements, combined with season of year and condition of vegetation, form the basis for rating the day's fire danger. The operator of a danger station can determine the type of a fire day quickly, accurately, and without personal bias by using the 100-point fire danger meter. This automatically gives the key factors their proper weight. First, he sets the vegetation condition dial on cured. Next, the season of the year factor is set at 3, since this observation was made in March. Then, last rain in inches is taken from the daily record. Same for days since last rain. Fuel moisture measured 7. Wind velocity 6. These factors make the meter register a burning index of 50. This makes it a Class 4 day. The ratings are expressed in numerical classes from 1 to 5, each having definite meaning and calling for definite action. A Class 4 day means very many fires spreading furiously. The fire station observer wastes no time in reporting to the district office. The district officer, in turn, notifies the local radio station to broadcast the warning to the countryside.
We interrupt our program at this time to make a special news announcement. The forest fire danger today is high in all southern counties of this state. Be especially careful with your brush burning, matches, and cigarette butts. Be sure they're out before discarding. Report any wildfires to your local forest warden. We repeat, the forest fire danger today is high in all southern counties of this state. Be especially careful with your brush burning. Report any wildfires to your local forest warden. The forest fire danger today is high.
Diagnosing fire hazards and broadcasting warnings do not by themselves stop fire from breaking out in your woodlands. If only all the people who use the woods cooperated with their state forest fire service, this could never happen again. The insurance is simple. Protect your forests, and they'll grow forever.